Okay, right, so we'll do a quick introduction to these things called line graphs, okay? Sometimes they're called time series graphs, sometimes they're called completely other things altogether. But the main times you'll see these labelled in your GCSEs, I know it's a way off, but they'll be labelled as line graphs or time series graphs. Sometimes you might get vertical line graphs, which look like bar charts with vertical lines in, but they're very rarely used, to be honest. And if you know what bar charts are, you'll know what those are. I'm not going to go into those. Okay, so let's have a look at some questions, some examples on these, shall we? First off, what have we got here? It says, below is a line graph that shows how many books are sold in a charity shop over 1 week. Okay. On the y-axis and the vertical axis, it shows the amount of books sold. And on the x-axis, the horizontal one, it's got the day of the week. Okay. Now, that's important. The vast majority of the time you will see time, a period of time on the x-axis, okay? Whether that is years, whether that's minutes, whether that's days or whatever, okay? Most of the time, the vast majority of the time, you will see time on there, okay? Right. So, let's have a look at these questions then. On which day did the charity shop sell the most books? Well, that just means the highest number of books sold. Which day has the highest number of books sold? What's the highest one? There it is on the Thursday. So for A, it would be Thursday. That's all you've got to write as your answer. Even if you put Thurs or Thu, that still be marked as correct, actually. B, in which day did the charity shop sell the which day did the charity shop sell the least books? Where is it lowest? I think it's on Saturday. Okay, and how many books were sold on a Tuesday? Let's get something like a ruler or a straight edge to see, shall we? Tuesday. There's Tuesday. We can see that it'd be 80. Okay, nice and easy, right? Good. Right, next up, below is a line graph that shows the population of a village. Okay, the data starting in 1970 doesn't always start right on this axis here. Okay, very often it starts just in the middle somewhere. That's fine, okay? Right, what was the population in 1980? Let's have a look, shall we? Let's use the other side this time. What was the population in 1980? So, get a straight edge. And now, it is 1 square above the 750, okay? Now you might notice that it goes 750 up to 800, and there are 5, I don't know how clear you can see this, but there are 5 divisions between them, 5 jumps up between 750 and 800. So you've got to think, what does that go up in? Well, if it goes up in ones, it's going to go 751, 752, 753, 754, 800. That's not right, is it? Is it going to go up in 5s, 10s, 20s? Have a think. It actually goes up, so if it goes 750, 760, 770, 780, 790, 800, that works. Goes up in 10s, okay? So, from 750 up 1 block, it's going to end up on 760, okay? You know, sometimes when it's not so clear, they give you a bit of leeway, but in this one, it's clear enough to read, all right? In which year was the population 700? Okay, so where is it at 700? 700, it is at 1970. Okay, so question B is 1970. Okay, the population is expected to increase by 120 by 2020. Work out the expected population by 2020. Whoops, ignore that. Work out the expected population in 2020. Right, so increased by 120. Well, let's have a look at the population in 2010. Okay, population in 2010 is 980. So the pop in 2010 equals what was that? 990 it looks like, and it's meant to rise by 120. So add them together, we're going to get about 1,110. Okay, right. Now, next question. It's showing us the price of unleaded petrol in England over 5 years. Let's have a look at that then. Now, in this one, you're actually going to have to draw the line graph yourself. Thankfully, it gives you a template, and I've already drawn it out on a whiteboard myself, so I don't have to write on my laptop. Right, okay. So, in 2011, the price in pence is 111, £1 and 11 pence. Okay, so 111 would be about there. I've not got any really small lines on this, so that's I've got to kind of estimate where that is. 2012, it goes up to 128. Bit of a jump, bit expensive. It's really expensive in comparison to nowadays. Filled up my petrol at £1, 1p per litre the other day. Anyway, 2013 jumps up again to 133. Right, that goes about there. Then 132 in 2014. So 2014, 132 has gone down a little bit. And then 2015, I'm going to have to bring this in a little. 2015, it goes all the way down to 108. 108 is about there-ish. Okay, and then we can just join these up with a straight line. Okay, what can I use for a straight line? I'm going to use this whiteboard here. Again, I don't have to start right at the start. I'm going to try and get this as good as possible, but it's going to be quite difficult. There we go. There we go. There we go. And have I rubbed one of them off? No, I haven't. Okay. And there we go. Oh, and there we can see the price of petrol over these years from 2011 to 2015. You can see it goes up quite sharply, goes up a little bit, goes down ever so slightly, then takes a massive drop. It's a really nice way to actually look at the data. You'll see a lot of line graphs in the news. Okay, between which 2 consecutive years did the price increase the most? Well, first of all, what does consecutive mean? That just means in a row. Okay, for example, 2011 and 2012, they are in a row. Okay, whereas 2011 and 2015, they're not in a row because they're not next to each other. All right. Which 2 consecutive years did the price increase the most? Well, you can see where the steepest part of the graph is, can't you? And that's here. Okay. It increases a huge amount there, then a little bit there, and then it drops and drops again. Okay, so the sharpest increase would be from 2011 to 2012. Okay, so that's what your answer would be there, 2011 and 2012. Okay, so that's a very, very quick introduction to line graphs. Okay, there are some other ones here to complete the line graph as well. Have a look. So 20%, 11%, 24%, 30% in 2001. 16% in 2006, that would drop down to about there, and 2011 goes up by a little bit. Now, you might notice on this one that it goes 1986, 1991, 1996, 2001, and so on. So in this case, you can see that the squares, the plots aren't on the bold straight lines. They're on the slightly off ones because it's not in 1990, it's in 1991. It's not in 1995, it's in 1996 and so on. Just got to be careful of that. Just got to be mindful of that when you're doing line graphs. Also, same rules apply when you're drawing the graph. You've got to have labels on the axes. They've got to be equally spaced in time. Okay, you can't go 2011, 2013, 2014, 2020 and so on. They've got to be equal in spacings, okay? Just like this one, you can see this axis at the bottom is equally spaced there, equally spaced, and these ones, they go up at a day at a time, so it's equally spaced, all right? And also, you might notice that some of them have these little squiggle here. There's a little squiggle there as well. That just means that some of the data we've skipped because we don't need it, okay? Because if we put in, 80p, 60p and so on, we're going to have a big old graph, but with only a little bit of data kind of squidged in at the top, all right? Just some things to be wary about when you're drawing some line graphs. Thank you very much.